All right, so let's continue the indefinite integral by substitution method. Continued. Okay. And this one you can see it's pretty obvious that we choose u to be the power to e. And if we take a derivative of this u, you can see that's going to be equals to negative t raised to the power of 4 if we differentiate u, right? If we differentiate u du dt, and that's going to be equal to negative 4 t times t to the power 3, sorry, dt to the power 3. And when we multiply both sides by dt, right, so we will get a du equals to negative 4 times e to the power 3 dt. Okay, so that's how we get from here to there. And oftentimes you can just go directly there. Okay. So now let's complete the substitution. Complete the substitution. I got, this is a u, right? T to the power 3. I'm going to bring it with dt and I can solve for it, right? So that's going to be negative a quarter, and that part is substituted by du, right? I hope everybody's getting better at this time, okay? And the antiderivative of e to the power u is e to the power of u plus a constant. Last but not least, okay, we will replace u by its equal, which is a negative t to the power of 4. Finished, right? Once again, you show your work nicely, and the substitution part, you show it on the side. You can show all of these steps vertically, but for me, I have to make a lot of adjustments because they're on the same line, right? So this is easier for me. Now, the next question. Okay, of course, we're going to still doing substitution method. And remember, we always try to make it simpler, okay? The substitution method is intended to make things simpler. So let's try this first, okay? So du equals to negative sine t dt, right? The derivative of cosine t is a negative sine t. And then substitute, okay? So we're gonna bring this down. So this is the root of u sine t. I'm going to bring it with dt, right? So I have sine t dt. There's a negative sign in front of it. So sine t dt can be replaced by negative du. You can write it this way, right? And on the next step, of course, you can bring the negative sign. You need the parentheses here, okay, on this step, if you write it this way. So you bring negative sign outside, then you don't need parentheses, okay? And you don't have to show this one. You can show this one directly. They're the same, okay? Next step, we got negative sign. The antiderivative u, root u is 2 over 3 u raised to the power of 3/2. Okay, plus a big constant. Okay. Last but not least, we're gonna have to bring the u back, okay, in terms of t. So our u will be replaced. There. Finished. That's the answer. Okay, 13. 13. Okay, so we're still doing substitution, and this substitution is pretty much similar to what we did before, but let's do it anyway. Okay, because I do want to show you how to show work. How to show work. I like to you can bring the t down here. Okay, so pi over 3 is treated as a constant. Sometimes in the textbook, they put a parentheses there. I don't think the parentheses is necessary, so I removed it. Okay, so du would be equals to pi over 3 dt. Okay, so now what do we got? Now what do we got? dt, right? If you want to solve for dt, sometimes you can show your work this way, right? You're solving for dt. dt is equal to, we multiply the reciprocal, right? On both sides, right? On both sides, you multiply something. On both sides, we multiply 3 over pi. 3 over pi, right? We multiply 3 over pi on both sides. You see what I'm doing here? Okay. So dt on the side of dt, pi over pi reduced, 3 over 3 reduced. And so we got 3 over pi du. So this will be replaced by u. dt will be replaced by 3 over pi du. You see that? Okay. And now completely substituted into u, and 3 over pi is a constant. I'm going to put it in the front, and du, and we're going to work on the antiderivative. Okay, the constant will be kept in the front. The antiderivative cosine u of sine u is negative cosine u plus a constant. Okay, and of course you can bring the negative sign in the front. Oops, sorry. In the front, remove the parentheses, replace the u by its equal. Okay, replace the u by its equal, or you replace this by this piece. So you don't have to put parentheses. That's finished. That's finished. Next one, number 14, right? We need a cosine squared. The antiderivative cosine squared is tangent, right? But now we have a cosine, we have a secant squared 2 theta, right? So this obviously, we need a substitution, so we have u equals to 2 theta. Okay, so du equals to 2 times d theta. Okay, so for substitution, we're getting to here. All right, so 2 theta will be replaced by u d theta du. So d theta is half of du. Okay, so this is a half of a du. Completely substituted. Completely substituted. Okay, and next step, okay, I'm going to bring the half to the front. And now the antiderivative of secant squared, we can apply that. So 1/2 is the tangent u plus constant. Okay, and last but not least, replacing u by its equal, which is 2 theta. Boom, finished. Okay. Number 15. Number 15. All right. This question, the substitution is actually very obvious. Okay, we're just going to introduce 4x plus 7, which is the entirety of the denominator. So du would be equals to 4 times dx. Okay, so we got this piece substituted. This is u dx. Okay, dx is a quarter of du. Okay, so dx will be replaced by a quarter of du. Okay, from this relationship. And you can bring the quarter to outside if you want. Okay, quarter is brought to outside the integration. And what will be the antiderivative? 1 over u. Of course, everybody knows that. Right, so that's a quarter. Everybody should know that. So ln absolute value of u. Okay, see, this is very much used. Okay, remove that. And last but not least, we're going to substitute u back in terms of x. Right? Now we're getting something a little bit more complex. A little bit more complex. Number 16. Right? Number 16. All right? 15, 16. We see some fractions in the exponent, and we have another term here, y squared, but no fear, right? We have accumulated some experience by this time. So we're gonna introduce u equals to the entirety of the parentheses, which is a 4 minus y raised to the power 3. So du would equals to -3 y squared dy. Okay, so we're gonna continue to do the substitution. Okay, so follow me. If you already tried your own, that's good. So this piece is u, right? This is u. But y squared, I'm gonna bring it with dy, right? So y squared dy, y squared dy, y squared dy. Okay, let me use the next line. Y squared dy, y squared dy is equals to divide both sides by -3, right? So this is going to be 3 under 1. Sorry. Okay. -1/3 of du equals to y squared dy. So basically, you can see this as solving equation, right? Solving y squared dy, solving for dy, y squared dy. So divide both sides by -3. Okay, so that piece will be replaced by there. So this is replaced. Okay, The parentheses is necessary here. The parentheses is necessary here. Unless you want to bring the number outside, right? You want to bring the negative 1/3 outside, then you would not need the parentheses. So by this time, we will be able to find the antiderivative of u raised to the power of 2/3. So we're gonna use power rule. So 1 plus 2/3 and u raised to the power of 1 plus 2/3, that's like 5/3, right? So 5/3 plus the constant, right? So this is 3/3. 3/3 plus 2/3, that's gonna be a 5/3. So this piece is going to be 5/3. 3 and 3 reduced. So these details of calculation, I know you guys know how to do it. Okay, so this piece will turn into negative 1/5. Okay, last replacing u, and we're done. We're finished. Okay, substitution. Are we having fun? I hope so. I hope you guys are having a good time, right? And you're getting better at this. And maybe you can skip a couple questions that I did here, okay? But I do have the intention to cover all these questions so you have a place to find your answers if you have any doubt, okay? So in this case, we're going to assume the entirety of the denominator equals to u, okay? du is equals to cosine theta d theta. Okay, u equals 1 plus sine theta, then we differentiate, right? And that's cosine theta d theta. So we got the cosine theta multiply d theta there, right? So this looks a little intimidating, which is a big function, but it is really not. So this is u, and that piece cosine u, right, with du, that's just cosine theta times d theta, that's really du. Okay, and next, antiderivative. ln is safer in this case to use absolute value plus constant. Okay, because this function has a domain, you know, except numbers that will cause the denominator equals to 0, but it could be positive and negative, right? So that's why we want to use absolute value. Last but not least, u is equals to 1 plus sine theta. Okay, so these will be very good practice for you algebraically. Okay. Let's see, where's my, okay, substitution rule. Okay, I just want to bring it next to me. All right, so this one, I have no doubt you know how to do it. So if you need to skip it, you can skip it. But I'm going to just go ahead and do it anyway. Just in case you want to check your answer. du equals to, or anyone likes to have some, you know, to check your answer. We're not sure how to show work. So dz, right? And over here, we have that's u, right? Z squared dz, right? Z squared dz, and that is 1/3 of du, right? So by this time, you guys probably is very good at this. 1/3 of it bring to the constant. And that equals to 1/3 ln absolute value of u plus a constant. And then bring the substitute u. There, finished. Right? I have no doubt you're doing better at this point. We will have some harder questions. We do. Okay, we will have some harder questions. But before we get to those harder questions, we want you to be able to do these questions more fluently. Okay, more fluently. So here I'm going to introduce u equals to cosine theta. So the u would be equals to negative sine theta d theta. Okay, u equals to cosine theta. The derivative of cosine is negative sine. And we got a sine theta d theta. So sine theta d theta is negative du, right? So then we're going to go ahead with the substitution. And you can see this part would just be u raised to the power of 3. And sine theta d theta, and if you like to see how it's being solved for, sine theta d theta is just really equals to negative du. Okay. And so this is a negative du. Okay, du, and you put a negative sign in the front. And almost there. Okay, so negative 1/4 u raised to the power of 4 plus a constant. Okay, and last but not least, replacing u. Okay, so this is the cosine to the power of theta. Done. Okay. So let's move forward. Let's move forward. There will be harder questions. Yes, there will be harder questions. So let's just practice with these. We're having a good time, aren't we? This one, the substitution should be pretty straightforward. U equals to negative 5r. Okay, so du equals to negative 5 derivative with respect to r, right? And this substitution will lead us to, this is u dr. dr is negative 1/5 of du, right? So replace dr by du, we have a negative 1/5 as a constant. And then we're almost there. Okay, we keep it here. The antiderivative e to the power u is e to the power u, and plus the constant. All right. And the last, of course, we're going to show the final solution. Okay, so I want to make sure you guys have a place to check your answer in case. And of course, you can always check your answer by taking derivative of your answer. All right, but in terms of how to show work, I think we have shown enough. But I do intend to finish these. Okay. Okay, so this time I'm going to assume Okay, this is with respect to u, right? So we cannot introduce another u. And be aware, how about we use w? Okay, w equals to 1 minus e raised to the power e, 1 minus e raised to the power u, right? So dw equals to negative e raised to the power u du. Okay, or you can introduce x. Why not? Right? You can introduce x. Since we started with w, we just keep it as w at w. Okay, you do have freedom to choose these variables. And so 1 minus e to the power u, that's w. E raised to the power u times du, that's negative dw, right? That's negative dw, negative. Power rule, and this is 1 over w squared. And so the answer is 1 over w. Okay. So the antiderivative of 1 over w squared is a negative sign in front of it. So the antiderivative is 1 over w plus a constant, sorry, plus a constant. Okay. And last but not least, okay, we got to replace w. There. Finished. All right. Number 22. Okay. Number 22, we're going to use u equals to 1 over x. Okay, so du would be equals to negative 1 over x squared dx. Okay, we got 1 x squared under dx, right? So you can see this piece is just negative du. All right. So bring this part over. Okay, so this is a u x squared under dx, right? So I'm going to bring that under dx. Oops. Okay, so that's x squared dx, right? Bring this under so you can see this more clearly, or you can show your reader more nicely. So this piece is a negative du, right? So it's du, and bring the negative sign in front, and just sign u. Okay, equals to negative, the antiderivative sign u is negative cosine u, right? And negative cosine u plus a constant. Then you can also write it as a cosine u, right? And last but not least, replacing u by its equal. Finished. All right. So now we got an interesting. Okay, so this, how do we work 23? In 23, you notice there's a, there's a b, all these unknowns, right? And no fear, because a and b will be regarded as parameters, okay? Especially a, b are regarded are parameters. Parameter means that they're relatively fixed. They're parameters, okay? You don't have to worry about them. You don't have to worry about, because we're integrating with respect to x. Or in other words, you treat AB as a constant, which you treat AB as constant. The obvious substitution here would be what's underneath the square root. Okay. Then you say, well, can I introduce the entire root? Because then you're going to make your question too complex. Okay. So what I like to do is you want the substitution to be simpler, but hopefully it will, resolve the integration problem. Okay. So du, it would be equal to 3a, you treat a as a constant, plus 3b x squared dx. We need this parentheses here. Because we take a derivative of 3ax, which is 3a, and we take a derivative of b times x raised to the power 3, we bring down the 3. So 3 times bx squared dx. And on this expression, right? On this expression, we can bring out the 3 factored out. And what do we see in the numerator? It's a plus bx squared. This is one of those academic questions that they want to make sure we will get the solution, okay? So do not be afraid. So this is our u, and the top part, multiply dx, that's just 1/3 of du. So replacing dx by du, we will have a constant in the front. Okay, so that's the substitution. Now everything entirely substituted, and we just have to find the antiderivative, and u raised to the power of a -half. Okay, and power rule. So we got 1/3. Okay, multiply, you just apply your power rule, 1/-1 plus 1 u raised to the power of half plus a constant. And this is going to be a positive half, right? And flip it over, so this is going to be 2. So we got the answer to be 2/3. U will be substituted. U is substituted. Finished. Right, so in this question, I can see the hardship would be, what I'm going to do with AB, well, just treat them as constant. Okay, treat them as constant. 24. Okay, 24. 24. Okay, 24. I'm going to introduce the entirety of the denominator as u. See what happens. Okay, because that would make things easier. Du, excuse me, would equal to 6e, right, plus 6. And then dt. You see, these are typical academic questions. They didn't mean to make our life so difficult, right? There's a solution. We just have to find them. So substitution. So we're going to do the substitution now. Okay. Substitution, the bottom is u. T plus 1 times dt. T plus 1 times dt, that's 1/6 of du. right? So this is changed to du, and that's going to be 1/6 in the front. Okay, and almost done, almost done. So 1/6 ln 1/6 ln absolute value of u. Okay, plus is constant. And last but not least, and bring back the replacement of u. Finished, right? So the more we do, the better we're going to be at this. Number 25. Number 25. You may like to pause to say, what I'm going to substitute this by? How I'm going to introduce the u, right? So try different things, okay? All right, so I'm going to introduce ln x as my u. Okay. So du equals to 1/x, oops, dx. And we got dx divided by x, dx divided by x, right? See, these academic questions, to set it up for us to solve it, for us to solve them, okay? So this is a u squared dx over x, that's du, right? So this is du. Okay, so u squared. So u squared. There we go. We will find the antiderivative in no time. Okay, so 1/3 u raised to the power 3 plus constant. I'm sorry, not adding constant, not equal constant. Okay. And last but not least, we're going to substitute u by ln x. Ln x. Okay. Number 26. Number 26 is the composition of a trig function. Composition of a trig function. Okay. No fear. No fear. I think by this time you may like to take a pause and to go ahead and do what you know, to work with these questions and come back to check answers with me. If that's what you want to do, no problem. Okay. So now I'm going to introduce u as cosine x. I think this question is pretty obvious. Okay. So cosine x. And my du would be equals to negative sine x dx. Okay. So in my substitution, this is u sine x times dx. Sine x times dx, that's negative du, right? So sine x times dx, right? Sine x times dx, that's a negative du, right? So put du there, put a negative sign in the front. And we're almost done. We're almost done. The antiderivative of sine u is a negative cosine u, right? It's a negative cosine u. Oops. Negative cosine u plus constant. And negative times negative makes positive. And last, substitute u. Okay, and u equals to cosine x. So this u will be substituted, cosine x. It's basically cosine of cosine x, right? It's a composition of a trig function. Okay, our question actually gets a little bit harder. Look at number 27. Look at number 27 and looking ahead at number 28. Okay, pause it if you want. But I'm just going to go ahead so you have, so we have a solution set. Okay. What are we gonna do, right? You think of the relationship between tangent and secant squared. The derivative of tangent is secant squared, right? So that gave us the clue. So I'm going to introduce u equals to tangent theta. Okay, so in this expression, you can also shift, you can also, switch tangent and secant. Okay, and next you see du equals to secant squared, secant squared theta, d theta. All right, so secant squared theta d theta, right? So this will give us the perfect opportunity to resubstitute. This is a u raised to the power 3, and secant squared d theta, that's du perfect. Those academic questions, right? They did not mean to make our life impossible. There is a way. There is a way. Okay. We just have to, work on it. We just have to work on it. Last but not least, the answer would be tangent theta substituting u. Okay. And bring the theta over here. So we use the way that we would typically write it that way. 28. 28. What are we going to do? 28. All right. Let's not be too far. Okay, so what I'm going to introduce as the substitution. Right? I think the most intuitive way, because we want to make it easier, we want to make it simpler. Okay, so I'm going to introduce u equals to x plus 2. Then du equals to dx. So that piece is u, dx is du. So this is du. Then you say, how am I going to replace the x? What are we going to do? No fear. This time, instead of, dx equals du, we can substitute x according to this relationship, because in this relationship, x is equal to u minus 2. Okay, so we're going to take u minus 2 to replace x. So now entirely replaced in terms of u. You see that? Okay, so I think this part might be the hard part. This part might be the hard part. Okay, and now you got it. Now you got it, right? So how are we going to integrate this? Well, we're going to do this. Okay, we're going to do this. We're going to have, of course, we still have the integration sign. Sorry, we still have the integration sign here. We're going to take a root u times u. So that's going to give us u raised to the power of 3/2 minus 2 times root u. That's u raised to the power of half. There you go. You got it. So we're just going to apply power rule, and we're done. Okay. Equal to the antiderivative of each one. So this is going to be 1 plus 3/2, and then u raised to the power of, u raised to the power of 5/2. Minus, there's a 2 times here. right? Be patient with ourselves. Okay, so 1 plus half u raised to the power of 3 halves plus a big constant. And the rest is reducing and substituting back. Okay, so this is going to be 5 half, so this is 5 under 2. And this is going to be 3 under 2. And 2 times 2, that's going to be 4 over 3. And substitute u back to our expression. Okay, u is x plus 2. So I'm going to replace u by x plus 2. I'm going to do the same replacement for the other u. And we're finished. Okay. Number 29. Number 29. How are we going to substitute? Right, so I'm copying this whole thing here. So we're going to figure out, then we're going to figure out how we're going to substitute. I think, okay, so here is the power, right? So we want to make it simple, right? So we're going to find u equals to x squared plus 2 over x. So that way du will equals to 2x subtracting 2 over x squared and dx. Factored out the 2. Okay, factored out the 2. Wait. Parentheses here, right? And this happened to be the same. All right. So once again, I'd like to tell you that those academic questions, they didn't mean to make our life impossible. Okay. So this is a u, and what is this? This is half of du. Half of du. Okay, and then the answer is going to be right here. Okay, so it's going to be 1 over 6 u raised to the power 6 plus the constant. Okay, and that's going to be, of course, 12. Whoops. Plus c, sorry, I keep having equals c. Let's just write another line. Okay, 1 over 12. So this is going to be 1 over 12. U will be replaced by its equal in terms of x. All right, so let's look at 30. Let's look at 30. And after this one, we're going to take a break. We're going to do the rest in another section, okay? 30. And in this question, we assume a cannot be 0. Okay, this is basically to guarantee that, you know, x will be present, right? If x is not present, it's a constant situation, so it's trivial. It's trivial. So we're going to assume, okay, so what are we going to do with AB, right? You treat AB as a constant. We treat AB as a constant. So we're going to introduce u equals to ax plus b, right? So du would be equal to a times dx. so ax plus b, that's a u dx, right? Because a is not 0, so we can solve for dx, right? So dx equals to 1 over a du. Okay, so dx will be replaced by 1 over a du. Okay, and this side is substitution. And next, 1 over a is treated as a constant. We move it out. And the antiderivative 1 over u is just ln absolute value of u plus a constant. Okay, almost done. Almost done. So u will be replaced back in terms of x. Finished. Okay, we just did 20 questions in this recording, and I think I'm going to stop this recording. And for other questions in the follows, and it will be in the next recording. Thank you for watching.